Imagine a single fish. For just this single organism, it can be relatively easy to determine the requirements that shape its weight, diet and lifespan, and determine the biomass of its species population as a whole within a certain area. But no fish exists as a single discrete unit. They are instead parts of a much larger ecosystem. All organisms that interact with this fish, whether in terms of predation or prey, also have a specific set of requirements that dictate their biomass. How can we determine the biomass requirements for every species within an ecosystem, and the ways this biomass moves between different species through processes of production and consumption? The answer lies in Ecopath. The Ecopath programs create a model which represents a static, mass-balanced snapshot of the resources in an ecosystem and their interactions, represented by trophically linked biomass pools. Now this is quite complex, so let's break it down a bit. A model is a consistent description, in this case of the resources or biomass within an ecosystem. These can take the forms of text, graphs, or equations describing states and rates. A static mass-balanced snapshot refers to the fact that the model is describing the ecosystem not over time and space, but in a single moment of time, accounting for all material entering and leaving the system, whether this be via migration or mortality. In terms of resources, interactions, and biomass pools, within the Ecopath model, resources are represented as biomass pools. These pools are defined as species groupings, meaning that the resources and their interactions can be understood as the movement of biomass throughout the ecosystem. So, in other words, Ecopath gives us a consistent description of how the biomass of certain species groups and how this biomass moves within and between species groups at a single point in time. This model can thereby tell us the biomass budget for an ecosystem, which is the difference between the production and loss of biomass within an ecosystem. Ecopath acts under the assumption that the ecosystem exists under equilibrium conditions. This means that the ecosystem is existing in a balanced state that keeps population size within a sustainable range, with enough species existing at each trophic level to sustain the entire ecosystem. If an ecosystem is balanced, biomass produced and lost are equal, meaning production minus loss equals 0. Therefore, Ecopath can tell us exactly how much biomass production and loss is needed within species groups in order for an ecosystem to maintain an equilibrium state, and can thereby allow us to estimate unknown biomass of a certain species group that would be expected in a balanced ecosystem. Before attempting to model the biomass in an ecosystem using Ecopath, you need to define the biomass pools, or species groups, that you will be applying the model to. The organisms within these groupings should share a trophic level and hold similar life history traits, such as reproductive behaviour, life stages and lifespan, and similar population parameters, means a similar mean and standard deviation population size. As long as they share these factors, the level of specificity is up to the user, with more restrictive groupings giving more detailed model output, whilst more aggregated groupings will give broader outputs. Once these are defined, Ecopath calculates the annual production and consumption of each species group with two master formulas. For each species, production can be calculated via production equals catch plus predation plus migration plus biomass accumulation plus non-predatory biomass mortality. And consumption can be calculated by consumption equals production plus respiration plus unassimilated food. In order to fill in these formulas, there are 6 major parameters that Ecopath needs to know for each of the species groups: biomass, total mortality or production to biomass ratio, PB, consumption to biomass ratio, diet composition, fisheries harvest, and ecotrophic efficiency. Let's break these down a little more to understand them. Biomass is defined as the total quantity or weight of organisms in a given area or volume, and is relatively easy to measure in grams per metre squared. Total mortality is related to production in terms of how fast a species group grows and dies. For most fish groups, where growth rates follow a von Bertalanffy phi curve, and mortality rates are negative exponential, their total mortality is derived from fishing mortality and natural mortality. For primary and secondary producers in these ecosystems, whose growth is more likely to be linear, their P/B ratio can be calculated as the reciprocal of their mean age. Consumption to biomass refers to how much species groups eat and how much they are eaten. Ectotherms usually have a lower Q/B ratio than endotherms, and can be estimated via oxygen consumption or using the aspect ratio of the tail. For both P to B and Q to B ratios, literature is often referenced to get general species group estimates. Diet composition refers to what species groups are eating, given as a fraction by weight of the species group it consumes. It can either be generally assumed from trophic level or determined from gut content analysis. Fisheries harvest only applies to groups that have substantial fisheries mortality from catches, discards, and poaching, and can be obtained from fisheries data. Ecotrophic efficiency refers to the proportion of production that's actually used in the system, or the remaining mortality as a proportion of total mortality. Since almost no system is truly closed, with production lost via migration, fishing, or predation that brings the biomass outside of the ecosystem studied, this value helps to balance the lack of precision in all other calculations. Even if Ecopath is missing some of these parameters for some species groups, it runs simultaneous linear equations to find estimates of the values for these groups and gives a rough output model that represents the flow of resources throughout the food web. These models can highlight areas of the ecosystem that require further research, or suggest expected biomass values for a balanced ecosystem that can be compared to those calculated. It brings together the work of many varied fields of research to shed light on ecosystem dynamics, aiding in policy making and management processes to help keep these systems in a balanced state.